factor completely. And these particular examples will all involve something called the difference of squares formula, or the multiplication of two conjugate binomials. Okay, so first step towards factoring should always be pull out the GCF. So if we look at 16x to the fourth and x to the fourth, y to the fourth, there's a greatest common factor of x to the fourth in both of these. And once that's pulled out in the first term, after x to the fourth is out, there's a 16 minus second term, x to the fourth is pulled out, we're left with y to the fourth. Okay, that's first step. Second step is to notice that 16 is a perfect square, it's 4 squared, and y to the fourth is a perfect square, it's y squared squared. So this will factor into two different conjugate binomials. The square root of 16 is 4, so I'll put that here and here. The square root of y to the fourth is y squared, so I'll put that here and here. And then I'll put a plus and a minus. And that completes an application, or applying the difference of squares formula, or the binomial, conjugate binomial product. Okay, now if we look closely again, in that last piece, the 4 minus y squared, 4 is a perfect square, and so is y squared. So we can repeat, we can actually use it again to get x to the fourth. This part's a sum, so that one's not going to be touched over the real numbers. But 4 has a square root. What's the square root of 4? It's 2. What's the square root of y squared? Well, that's y. First one's plus, second one's minus, and so there is the final answer. So notice first we pulled out a GCF, then we applied the difference of squares formula, then we did the difference of squares formula again to get the final answer. Okay, let's try another example. In blue, first pull out the GCF. In this case, z cubed. What's left over? From the first term, x to the fourth, minus from the second term, the number 81. Both x to the fourth and 81 are perfect squares. So in the next stage of the factoring, we'll write out two collections here. Square root of x to the fourth is x squared, so put that here and here. The square root of 81 is 9, put that here and here. First one plus, second one minus. Then, third step of factoring, the GCF is still there. The sum of squares is untouched, but the difference of squares, x squared and 9, can be factored even further. The square root of x squared is x. The square root of 9 is 3. First one plus, second one minus, or minus plus. I just prefer plus minus. So there's the final answer for that factoring. So why don't you try one on your own? Pause the video and try to do 2a cubed b to the fourth minus 2a cubed. Now, assuming you gave it a shot here, I actually made a big thing that factors out this time, right? You can factor out a 2 and an a and a cube. So what's going to be left over? From the first term, the b to the fourth should be pretty clear. Minus, when you pull out the 2a cubed, you've pulled out everything from that second term. So all that's left is the number 1. Notice that if you were to look at this like a distributive way to see if you did it correctly, 2a cubed times 1 is 2a cubed. Now, continue the factoring into the next stages. So, what's the square root of b to the fourth? That's b squared. What's the square root of 1? That's 1. First one plus, second one minus. Then, last stage, the b squared plus 1 is unchanged, but the b squared minus 1, this one can be factored down even further. The square root of b squared, b, the square root of 1, 1, make the first one plus, the second one minus, put a box around your answer, and a smiley face. You're done.